Good evening. Am I audible?
Yes, sir, you are audible.
Okay. Hello. Good evening, Gaurang sir. Welcome.
Yeah, good
Yeah,
evening,
good evening, sir.
Dr.
Yeah, thank you. Welcome, sir. Thank you for joining, sir.
It's indeed my pleasure.
Yes, yes, yes. Fine, fine, sir. I hope all good, sir. This is the last
Yes,
day, so yes, sir.
yeah, I think everything is fine.
Okay, sir.
I hope voice is clear.
Yes, sir. Voice is clear. Video, you can try your video, sir. Video presentation.
Can I share the screen?
Yes, sir. Yes, sir. Please check it out.
So I hope it is visible.
Yes, sir.
Okay. So can I stop sharing now
Yes,
or?
yes, sir. Please, sir. You can do later on, sir.
Good evening, everyone. We are soon going to start session. Good evening, everyone. Am I audible? Kindly let me know. Am I audible?
You are
Yes,
audible.
Gaurang.
Yes, Gaurang sir, shall we start?
Okay. Good evening, everyone. I'm very delighted to welcome in our fifth day of SPSS program. It is my privilege to extend a warm welcome to our distinguished keynote speaker for today, Professor Dr. Gaurang Rami. With over 20 years of teaching and research experience, Professor Rami brings an immense wealth of knowledge to this session. His specialization in econometrics, along with his extensive academic background, including a PhD, MPhil, and MA gold medalist in economics, has made him a respected authority in the field. Professor Rami's contribution to the academic background are truly commendable. He has authored numerous books, research papers, and chapters in edited volumes. He has been involved in over 12 research projects funded by prestigious organizations such as ICSSR, ONGC, and the United Nations Development. His experience as a professor at Mindanao State University and his past visiting professorship at university across the globe showcase his dedication to spreading knowledge internationally. Today, Professor Rami will guide us through our enlightening session on linear and multiple regression, followed by hands-on practice and a Q&A session. This practical approach will surely enhance our understanding of these essential statistical techniques and their application in our research. So we are truly honored to have you, sir, today, Professor Rami, and we look forward to your session with great anticipation. A warm welcome to you, sir, and to all the participants. Thank you so much.
Thank you, Lee Bon. I hope I pronounce your name correctly. So, thank you very much for introduction. Before actually I start my lecture formally, let me express my very profound and sincere thanks to School of Law, Rai University, and my own very close friend, Dr. Kalpesh Gupta, for continuously providing me this kind of an opportunity to be part of his ongoing workshop, training programs, specifically in the field of law, now not only in India, but even abroad also. So I extend my very, very sincere and profound thanks to Dr. Kalpesh Gupta for providing me a platform continuously. As has been already said by Libon, that I'm going to speak on regression analysis, and I will be focusing on linear regression, including bivariate linear regression and multivariate linear regression. So what I am planning that maybe in the first like half an hour or so, I will focus on the theoretical aspect related with the regression analysis, and I will bring couple of cases with me. So based on those cases, later on, depending upon the suggestions given by a participant, we will practice on one or two cases depending upon availability of time. So I have already circulated the PPT and the data sets to the organizer. So as lecture progress, we will decide, on which example we want to make some hands-on experience. So the main purpose is to discuss what is regression analysis and how one can use regression analysis specifically in the domain of law and the topics pertaining to law and other associated discipline. And then whatever case or the example you suggest, we will make practice on it. So let me just share my screen. In between, if any participant have any question or any query, they can hold me in between and they can ask the question, or they can keep their question for Q&A session, and at the end of the session also they can ask their question. So I hope the screen is visible to you.
Yes, sir. Yes, sir.
Okay, fine. Thank you. So before I directly jump on the bivariate and multiple linear regression, I have to take some topic as a base. So I will be taking a topic called correlation analysis, which probably Ambati Rao sir has already covered either day before yesterday or maybe yesterday in his session. So actually, when we learn correlation, basically what correlation analysis explain, whenever we have a two or a more than two variable, and when our objective is to analyze how these two or more than two variables are related with each other, then largely we use a technique called correlation analysis. So what ultimately correlation analysis tells us? It tells us that how two variables are correlated or related with each other, and we will have a two broad answer from correlation technique. Number one, what is the direction of relationship? Means whether these two variables are positively related or they are negatively related. And number two, what is the degree or magnitude or strength of relationship? So either they are strongly related, they are perfectly related, they are weakly related, or they are moderately related, or we can say if they are not at all related with each other. So when our main objective is to examine the nature of relationship between two variable, that what is the direction of relationship and what is the strength of relationship, then usually we use appropriate correlation technique from the literature. So depending upon scale of measurement and the nature of the distribution, we can choose either Pearson correlation technique or Spearman rank correlation technique or any other correlation technique. But basically, when our objective is to examine the relationship between two variables, its direction and magnitude, can use correlation. Now, majority or in many of the instances, our main objective is not only to examine the direction and strength of the relationship. Many a times we are more interested to know that suppose if there are some changes took place in one variable, how it's going to affect another related variable. So like suppose when we have a two variable called x and y, this x can be anything and y can be anything, and we'll try to understand this x and y using some appropriate name of the variable also slightly little bit later on. But then when our objective is to see how these x and y are related with each other, what are the direction and strength, then we can use correlation. But then when our objective is to know that suppose if there are some changes took place in the x, then what will be the likely change or likely effect that we observed on the y. So when our main objective is not only to examine the relationship between x and y, but our main objective is to see that suppose if there are some changes took place in y, what will be the likely change that has occurred in the y. Then we can use a technique called regression analysis. So when regression analysis comes into the picture, then identification of variable plays very important role. Now what I mean by identification of variable, suppose if you find out correlation coefficient between x and y or x and y, it will not change the answer remain the same. If you find out correlation between x and y or between y and x, either you use Pearson or Spearman or whatever it may be. But then that is not the case when it comes to regression analysis. Like I give you a common example from a different discipline, then I will focus on law and associated discipline also. Like take a very simple example of say price and quantity demanded. So usually what we believe that price and quantity demanded are inversely related with each other. Means if there is increase in the price or if there is a high price, people tend to demand less, and if there is a less price, then people tend to demand more. So this shows there is a inverse relationship exists between price and quantity demanded. But then you are more interested to examine or to know that suppose if there are some changes took place in the price, then what will be the likely change that you observed on quantity demanded. So suppose if prices are increased by 1 rupee or 1 unit, what will be the likely decrease or reduction you observe on quantity demanded? This answer we will get from regression analysis. And all of us or majority, we know that the basic structure of the regression analysis is some y is equal to beta 0 plus and minus beta 1 x. I'm going to discuss the importance of this U slightly little bit later. But when we focus on the model like y is equal to beta 0 plus or minus beta 1 x, this model is, or this regression line is known as deterministic model. Why deterministic? Because this x has a 100% capacity to explain variations in the y. So nothing is left out or nothing is unexplained. Usually in social science, in law, in economics, in psychology, or where behavioral factor plays an important role, there we hardly come across that there are some X which has 100% capacity to explain variations in the Y. Like say, suppose this Y is quantity demanded and this X is price of a given product. Now we know the price of a given commodity does not have 100% capacity to explain variations in quantity demanded. So demand of a given commodity is not only depend upon its own price. It may depend upon price of substitute commodity. It may depend upon price of complementary commodity. It may depend upon advertisement expenditure incurred by firm. It may depend upon the taxation policy of the government. It may depend upon income of the consumer. Now, these are the measurable variables. There may be some non-measurable variables also, like what is the interest of the consumer, what is the fashion prevails at that point of time, what is the habit of the consumer. So these are the qualitative variable or qualitative factor which also can influence the quantity demand. So that's why we hardly come across there is a single one variable which has a capacity to explain variations in the dependent variable. So when the number of independent variables are more than one, such regression is known as multiple regression. Now, what is this U, or what is the stochastic model? Stochastic model or U is nothing but it is a amount of error which by knowingly or knowingly presents in the regression model. So from beta 0 to beta 1 x, this is a explained part and this is a unexplained part. So U is considered to be as error in estimation or error in regression model. So in statistics, it is known as residual or it is known as disturbance term. So when I'm going to discuss with example, I think probably the concept of residual or error are going to more clear in your mind. But right now you can keep in your mind that because of knowingly or unknowingly, there are some factors which we cannot incorporate into the estimation. So the combined effect of all those variables which we have not included in the model by knowingly or unknowingly, that is known as error or that is known as residual. So our main objective is what? When we use regression analysis is to minimize the amount of error. Let us take this example. Look at this graph. When you see these black dots, so these black dots are the actual values of the different combinations of x and y, we can say, where y is dependent variable and x is independent variable. So we are interested to find out some regression line in such a manner which passes through all these observations in such a manner where total error is going to minimize. So there may be millions of line passes through these dots. So we need some technique or we need some method which has a capacity to find out the line in such a manner where total errors are going to minimum. Like look at the example. Suppose if we think about the first observation, so this is the actual value and this is the same value given by estimated regression line. So there is no error, there is a zero error here. Same for the second dot also. But look at this third dot. This is the actual value of y. So y is a dependent variable. Maybe the third observation or third respondent. And our estimated model says this is the estimated value of y. So the difference between actual value and the estimated value is known as error. So we need to find out some regression line which passes through all these observations in a such a manner where this summation of error or the square of summation of error turns out to be minimum. Why square of summation of error? Just think in this way. There are some errors which are positive, there are some errors which are 0, and there are some errors which are negative. So when you take summation of error, suppose this is error of the first observation, say U1 or E1. This is E2, E3, E4, E5, E6, E7. So when I did sigma EI, that is E1, E2, E3, E4, it always turns out to be 0. Because from the estimated regression line, some errors are positive, some errors are negative, and some errors are 0. So that's why what statisticians have suggested that whenever you have a summation is 0, either in any equation, either into a denominator or above, you cannot do any mathematical work further. So that's why they suggest to take square of the error. So that is sigma EI square or a sigma UI square. So our main objective is to find out some regression line which passes through all these observations in a such a manner where square of errors are going to minimize. And that's why the technique which is used to estimate this kind of a line is called least square error, or that method is known as OLS, stands for ordinary least square method. So errors are bound to happen when we use regression analysis. Regression is always a trial and error. So we have to check different combinations in the regression analysis, and depending upon certain parameters we need to decide which regression model is considered to be as superior or better compared to rest of the others, because our dependent variable is usually depend upon more than one variable. So when we use more than one variable, such regression is known as multiple regression. So I'm not going to focus more on this, otherwise it will create some trouble in your mind. These are the couple of assumptions of the ordinary least square method or a methods of least square. Right now I am not much focusing on this also, because this is the part of a discipline called econometrics. So whenever we use any regression model or a regression line, we have to check whether it follows the assumptions or not. Like regression model is linear in its parameters. So this alpha and beta are parameters, whereas y and x are the variables. For given x, the mean of ui is 0. As I already mentioned, when we take sigma ui and its mean, it always turns out to be 0. For given x, the variance of ui, that is the variance of error, is constant. So that is measured through sigma square u. So that is known as homogeneous variance. Don't worry about all these points right now. It says errors are also independent. So suppose if there are say 10 respondent, you have a 10 sample size of 10. So error of x1 should not be related with errors of x2. So your error should not be correlated with my error. This is what it says. So when the errors are correlated with each other, it is known as autocorrelation. So regression analysis or OLS technique assume there should not be autocorrelation. Same kind of variable are known as independent variable. So there is a one assumption that independent variable should be independent to each other. So what if x1, x2, x3, xk are related with each other? So it raises one problem called problem of multicollinearity. So we need to check all this also when we progress ahead. So right now I am not focusing on these very seriously. Similarly, the number of observations must be greater than number of regressions. So our sample size should be greater compared to our number of independent variables. So that's a n is greater than k, or k should be less compared to n. Model specification, so model should be linear. So power of x1, x2, x3 should be 1. It should not be like x1 square, x2 square, or x3 cube. If the power is more than 1, it is not linear regression. It is either a quadratic regression or a cubic regression, and so on. And the disturbance term or an error term should be normally distributed. So these are few assumptions. What is the difference between correlation and regression? Correlation examines the relationship between x and y. So it gives me answer the direction of relationship and magnitude of relationship. What is regression? It tells me that suppose if x changes by 1 unit, what will be the likely change occurred in the y. So this is a difference between correlation and regression. Now let me come to couple of cases or couple of examples so that our concepts are going to be more clear. So let us take very simple example. This is the first example. Say, what is a research question? That does the number of legal internship months and GPA, that is grade point average, predict success in bar exam score or not? So suppose if there is some researcher who is interested to figure out or to find out that what is the contribution made by legal internship months and GPA in the success of bar exam score. So like say our bar exam score, that is out of 100, it is a dependent variable for us. So we assume that bar exam score depends on the duration of internship in months and the law school GPA on a 10-point scale. So suppose I have a data of 10 students. I draw a sample from some class or from some institute, and I ask them, okay, what is the duration of their internship? What is the GPA of there, and what is the score they have in bar exam score? So depending upon these data, I want to predict a regression model. So suppose based on this regression model, I can predict that suppose if somebody spent say 4 months for internship, and if their GPA is say 8.5, then what will be their bar exam score? So this is the basic purpose of the regression analysis. So when I take only one variable, like suppose if you take bivariate regression, so there I consider only one variable. I am not focusing on GPA. So there I say bar exam score is a function of internship. So that is only one variable. Now we know that performance in the bar exam score is not only depend upon the internship. It depends on so many other factors also. But then I have a data of internship only. So that's why I use only one variable and try to know what is the contribution made by internship duration in generating bar exam score. Now I have a information of the GPA also. So I extend my model. I will increase x2 here also. So my regression is my model is what? Y plus b1 x1 plus b2 x2, where x1 is internship duration in month and x2 is law school GPA and y is my dependent variable. So what is the contribution made by internship as well as GPA in acquiring bar score, bar exam score? So this model check both internship experience and GPA together predict bar exam success more accurately. Let us take another example. So this is from law and education. So I have a case from law and education, I have a case from law and economics, and I have a case from law and criminology. So I'm not going to spend more time on the cases, because once when we understand the case, then later on we will practice this also. So suppose, so this is the second case that we have. So what is the topic of the research? The analyzing the impact of legal education and court exposure on law graduates' career readiness. So the main objective of the study is what? To empirically examine how factors like internship duration, moot court participation, and GPA affect the career readiness of law graduates. So suppose, say, Dr. Kalpesh Gupta is interested to examine this kind of a regression model. Like, so what are the research questions? That does the participation in moot court competition influence the self-perceived career readiness of law student, and to what extent do the academic performance and practical exposure, that is internship, and soft skill training explain variations in the career readiness. So what is our dependent variable? Our dependent variable is career readiness score. So either this is self-reported by the student, or it is given by the faculty based on the assessment out of 100. And our independent variables are what? Internship duration in months. So that is a practical exposure. Now look at this variable, moot court participation. So this is a binary variable. So suppose if you have participated in the moot court competition or not. So here we are interested to see those who have not participated in the moot court participation and those who have participated into the moot court participation. Whether the readiness, whether the career readiness of a law graduate is more or less. So here we want to compare those who have participated, whether they are relatively more ready compared to those who have not participated into the moot court. That's the objective. Then the third independent variable is law school GPA. Fourth, communication skill score. So it is out of 10 based on the faculty ratings. So this is a soft skill. And legal research skill score, that is out. This is also out of 10 based on the research ability. So our model is like this. So career readiness is equal to some beta 0 constant plus beta 1 internship plus beta 2 moot court plus beta 3 GPA plus beta 4 communication skill plus beta 5 research skill, and there are some error. So we know career readiness is not only the function of this 5 variable. It is a function of some other variable also, which we have not included in the model. So suppose these are the data of 12 students. So maybe Professor Gupta have collected these data from the 12 student, and based on this information we are interested to estimate the regression model and try to estimate what is the contribution made by internship for career readiness, whether career readiness is higher those who have participated in the moot court compare with those who are not participated, contribution made by GPA, communication skill, research skill into a career readiness score. So what is the practical use of this research? So it will have a policy impact, like it helps university and bar council to improve curriculum structure. For curriculum design, it emphasizes skill-based training, so moot court and internship, if their contribution turns out to be higher. Career services, like highlight what makes students job ready, and law firm hiring. So it predicts which factor to look for in fresh graduates. So they focus more on internship or focus more on participation in moot court, GPA, communication skill, or a research skill. Let us take the second example from law and economics. So here researcher is interested to use regression analysis for estimating impact of regulatory quality and judicial efficiency on ease of doing business across the state. So suppose you have a secondary data, on different states, and this is from say law and economics background. So the main objective is what? To analyze how judicial efficiency and regulatory quality impact the ease of doing business in Indian states. So our dependent variable is what? That is the ease of doing business score. That's a state level data out of 100, and these data are easily available from the government's website. And what are the independent variables that we think? So judicial case disposal rate, that is a measure of judicial efficiency. So if the judicial case disposal rate is higher, it says the judicial efficiency is more. If it is lower, it is low. So judicial case disposal is positively contribute in ease of doing business. Number of economic regulations per state. So this is a proxy for regulatory burden. So if the number of economic regulations are more, there is a more burden. If it is less, it is a less burden. Average time to resolve commercial disputes. So if it is taking more time, ease of doing is less. If it is taking less time, ease of doing is good. And number of judges per lakh population. So this reflects the legal resource availability. So if the number of judges are also less per population, it will adversely affect the ease of doing business. If there are more judges, it has a positive contribution into ease of doing business. So the sign of respective variable is positive or negative. That will purely depend upon your theoretical and conceptual framework. So right now I keep it positive everywhere, but when I actually estimate some beta, like beta 2, beta 3, or some turns out to be negative also, which indicates it has a negative effect on the ease of doing business if their number is higher. So suppose say these are the hypothetical data that we have. So we have a data for few states like Gujarat, Maharashtra, and so on. So this is a score of ease of doing business. This is a disposal rate. These are the regulations. These are time to resolve, and these are judges per 1 lakh population. So we can estimate the regression model and try to examine the contribution made by disposal rate in ease of doing business score, regulations into it, time to resolve it, and judges per lakh population into it. So what are the significance? It helps understand the legal institution bottleneck to economic development, inform judicial and regulatory reform for improving investment climate, and it may be useful for Niti Aayog or Law Commission or state government to decide policy regarding with the ease of doing score. Let us take the last cases, and then we will move on the article. So this is from law and criminology. So suppose there is some research scholar uh, who wish to examine how socio-economic variable influence the violent crime rate using legal and criminological lenses. So like the title of the research is what? Socio-economic predictors of crime rate, a legal criminological study of urban districts. And this is also based on the secondary data. Believe me, these data are easily available for different states, different cities, different locations, and you can actually use regression analysis to estimate the predictors for violent crime rate, per 1 lakh people. So the crime rate per lakh people is our dependent variable, and we believe, or depending upon theory, it depends upon unemployment rate. So as we know, if unemployment rate is higher, there is more crime, some theory says. Conviction rate for the violent crime, police personnel per 1 lakh people. So it also says if there are more police, there is a less crime. If there is a less police, there is a more crime. And urban poverty rate. So high poverty, high crime, low poverty, low crime, something like this. So here also some variable will have a positive like contribution, and some variable will have a negative contribution into the dependent variable, and whether it is positive or negative, that will be purely depend upon the subject matter in which you are doing your research. So the respective theory of your discipline will help you to decide whether the coefficient of a particular independent variable will be plus or it will be minus. Say these are the hypothetical data from different some district in from urban areas in India. So say these are the crime rate, and we know how we measure crime rate. Crime rate is per lakh population. Then unemployment rate, conviction rate, police per 1 lakh people, and the poverty rate. So what are the significance? So it understand the legal deterrence, that is a conviction rate in context of socioeconomics. So poverty, unemployment, these are some socioeconomic variables. It adds in urban crime prevention policy and law enforcement strategy, and it provides empirical basis for criminology theory, that is strain or deterrence. So these are the theoretical part. Now you let me know, suppose if you have some question, or you let me know which example we should practice. So then I will move on that data set. Can we practice law and education?
Sir,
Or we
internship will be good, sir. Participant, any your preference from your side? Any preference? Sir had discussed various examples. So, sir, this will be better, sir. First one, internship, because it will be easier. People can understand.
Yes, absolutely fine. So we can make use of this simple example also. Okay.
Okay,
So
sir.
what suppose if students are also interested to like estimate the regression model, then I will be explaining using Excel, and I will be explaining using SPSS both. So suppose if you do not have SPSS, then you can work in Excel also. Excel is also equally competent for regression analysis. There is no problem into it. So I will demonstrate in both the packages, and I have already shared the Excel file. So what I will do, first I will explain in Excel, and later on I will explain the same in SPSS also, that how you can take the same data from Excel to SPSS and one can estimate the regression model in SPSS also. So suppose if you have this data set, then you can find this kind of a data. So there are 4 cases. So this is for internship and other. This is for law and education, law and economics, law and criminology. So maybe I will explain one, and later on you can practice more as you have a time. So this will be fine.
Participant, are you okay with the sir? Okay, sir, please go ahead.
Yeah. So look at, this is how our data look like. The way we entered data, like in any package. So we have entered data like this. So this is our X1 internship duration. This is our X2 law school GPA, and this is our bar exam score. So we assume that bar exam score depends upon internship duration and it depends upon law school GPA. Now suppose if you have a Excel, I don't know which version you are using. So there is a one ready-made add-ins called data analysis. So if you have not installed that, it's very easy to install. How you can install it? Just simply click on this Excel, just simply click on this file. When you click on the file, find out options. Click on the options. So when you click on the options, this kind of window will appear. Then find out adds in. Click on the add-in. These are the various add-ins. So these are not automatically installed. When you install Excel, PowerPoint and Word on your computer. So click on add-in and find out add-in called analysis toolpack. When you find out, select analysis toolpack and then just click here on go. So when you click on the go, it will ask you which analysis toolpack you want to install. Just select analysis toolpack. And then you click OK. So the moment you click OK, it will take some time. And then one data analysis toolpack got installed in your Excel. So if you click, there is a menu called data. You click on data. You will find something called data analysis. Have you seen this? If it is already installed on your computer, there is no problem in your Excel. Just find out data analysis and click there. Look it. Whatever you learn in SPSS, everything is, most of the things are available. See, correlation, descriptive, ANOVA, all. Find out an option called regression. And then just click OK. Now see, you don't have to do anything. You just have to provide a range of dependent and independent variable. That's it. So here read input Y range. Just let me know, are you practicing with me?
Yes, participant, anyone practicing, sir? Some of them responded. Need to doctor just.
Suppose if you are practicing, then we can do simultaneously. Suppose you are practicing, just click here and provide input range. Input for Y. Y stands for dependent variable. So this is my Y. So I am just clicking from here and selecting this range. So it will say $D $1 gem $D $11. So this is the range. Suppose if you have 100 observation, you select 100. If you have 1,000 observation, you select 1,000. That's it. Now click here. Here we have to select input X. So X stands for independent variable. Independent can be 1, it can be 2 also. So let us we take both together. So I am selecting like this. So that is $B $1 gem $C $11. This is fine. Now see, in the first row, labels are located. So if we will not instruct to the computer or Excel, computer will consider bar, law, internship also data, and they are not data, they are labels. So we need to tell, we have to click here labels, so that Excel will understand that the information provided in the first row, it represent labels. Now look at, there are 3 choices for output. So actually where we need output. So we can take output in the same sheet also. If you need in the same sheet, you have to click on the output range and you have to give range here. By default it says new worksheet play. So this is always advisable. When you keep new worksheet play, means your data remains as it is and your all output will save automatically into the new worksheet. So it will not disturb your data remains as it is. So I keep new worksheet play as it is. I am not doing anything right now with all these options. You can do later on. Right now we keep new worksheet play and just simply click OK. Can you see the output? Does the output is visible to you?
Yes, sir. Yes, sir.
So suppose if output is visible to you for interpretation. See, these are our coefficients. If you read this, so these are the statistics which are important to interpret. So just let me, this is our regression model. Fine. Let me open the Word and try to explain more. See, this is our regression model, and these are the coefficients they are estimated. So I'm just copying this coefficient and paste here. So this minus 17 is beta. See, look at how our model look like. So how you can write regression model? This beta 0 is minus 17. I am taking say up to 2 digit, say 0.29, this is plus, so it is x1. So it's like internship in month plus beta 2. So this is 11.16, and that is my law school GPA. Okay. So can you see this regression model now? That is minus 0.29. Okay. Wait. This is minus. Fine. So how we interpret this value? It says our y is what? Our dependent variable. So our dependent variable is bar exam score. So this is how we can write our exact model. So it says internship duration and performance in the bar exam score are negatively related with each other. So if you spare more time for internship, that will reduce your performance into bar exam score. But if you look at the law school GPA, it has a positive contribution. So suppose if your GPA increase by 1 unit or 1 number, it will improve your performance into bar exam score by 11.16 numbers. If you increase your internship by 1 month, it will reduce your bar score exam by 0.29 marks. This is how we can interpret this estimated regression line. Now, if you come to the output,
So one
and
participant raised the hand.
yes,
Rajan.
yes, please.
Yes, Rajan.
Yeah, if you have any question, you let me know.
Yes, Rajan Sharma. Now please
Yes,
start.
sir. Sir, can we quickly go through the correlation function that we used in Excel?
So you want to find out, I don't know, how you learn correlation in Excel, but you want to learn correlation.
Yes, sir. The function, how we did it just now, because I lost one of the internet was hanging.
This is not correlation, this is regression.
Regression, sir. Sorry.
So you want to, you want me to repeat the same?
Yes, sir. Yes, sir.
Okay,
Please, sir.
okay, fine. So you know how to install this data analysis tool pack in Excel?
Yes, sir.
Yeah. So you just go to data, you will find option called data analysis. Click over there. You will find an option called regression. Click over there. Then provide the input range for Y. Provide the input range for X. Suppose in our case, this is our, like I will show you. So this is our input range for Y. This is a dependent variable. And wait, I have to go to this. Fine. Click analyze here, regression. So these are my input range for Y. These are my input range for X. Since there are label in the first row, I have tick mark label here and I ask new worksheet to play. So my all outputs are going to save in the new worksheet. Just simply
Right.
click OK and you will get this output. We don't have to write any function or any command. It's a menu driven procedure in SPSS. I hope it is okay.
Yes, sir. Yes.
Yeah. So this is how you can actually estimate the regression line. So based on the data that we have, it says internship duration is negatively associated and law school GPA is positively associated. As far as concern of our dependent variable, that is bar exam score, is concerned. So as a policy maker, these are the hypothetical data, as I said. So as a policy maker, if your grade point average is higher and if you have a less time spent on internship, your performance in the bar exam score is relatively better. This is what we can estimate based on these data. Suppose if you want, we can practice any of this example also. We have to do the same procedure. That's it. Let me know one more example so that I can make more proper interpretation of it. Can we do for law and economics or law and education or law and criminology? Let me know any example and I will explain that also and try to make more proper interpretation. Hello. Yeah, we can do law and somebody says criminology, somebody says, you let me know any one. You can unmute and let me know, so I'll practice. So can we do law and criminology?
Yes, sir. Yes, sir.
Okay, fine. So we have to follow the same procedure. See what I am doing? I am just clicking data analysis here, regression. I am deleting all this because these are my previous values. So input Y range. So I am clicking here and taking crime rates. Oh, I made a mistake. Wait. I need only crime rate, that is a Y. Now I click here and taking from unemployment to poverty. Unemployment rate to poverty, and then click on the label and saying same new worksheet play. I'm just clicking OK. That's it. Now can you see this output? I will make interpretation more appropriate now. So these are our coefficients. Let me take this. Suppose these are our coefficients. What is our regression model for crime? Let me take the regression model first. So this is our regression model. Now see, it says crime rate is equal to, let me take this and then I will make proper interpretation. So this is intercept, this is nothing but my beta. So I am taking 160.20 in place of beta 0. Now beta 1 unemployment, so I am just, you can say either 0.50 or 51 because next point is 9. Sorry. Control C. This is my beta 1 unemployment. 2.83. This is minus. You can see minus here. So I am saying minus control V. Then this is positive 0.47. This is my beta 3 and 0.002. This is also negative, you can see. So minus this. Say this is my estimated regression line based on the data for selected states. Now how we can interpret this? It says holding poverty rate constant, police presence constant and conviction rate constant. If unemployment rate increases by 1%, this will increase crime rate by 0.50 unit. How crime rate is measured? Let us we try to read. Crime rate is per lakh population. Fine. So what is the interpretation? That if unemployment rate increases by 1%, it will increase crime rate by 0.50 number. If conviction rate increase by 1%, it will reduce the crime rate by 2.83 unit. If police presence increase by one number, suppose if there is an increase in the police force by one number, then it also positively contributes for crime rate. If poverty is increased by 1 unit, it will reduce the crime rate by 0.0002. So what it says, poverty and crime rates are not meaningfully associated. But certainly unemployment are positively contributes in crime rate. Conviction is negatively contribute in crime rate, and even police presence is also positively contributes in crime rate, which is I think goes against the basic understanding, because we believe if there are more police, crime rate is less. So this is something which is of worry as far as concern of regression model is concerned. Now, what is the contribution? This adjusted R square is very, very important. What is the contribution made by this 4 independent variable in dependent variable, that is in crime rate? So value of adjusted R square is 0.94. If you multiply this with 100, it turns out to be 94. So the interpretation of adjusted R square is 94% variations in dependent variable are together explained by all these 4 independent variables. So 6% variation in crime rate, that is 100 minus 94, 6%. 6% variations in the crime rate are explained by some other factors which we have not included in our regression analysis or in regression model. So higher the value, higher the explanatory power, lower the value, lower the explanatory power. This is how we can make interpretation of estimated coefficient. Now suppose if you want to do the same using SPSS, so what I am doing, I am just copying this file, copying this data, Control C. Suppose this is SPSS. So I am just right click here and there is an option paste with variable names. Just clicking here. So now look at the same data I have here. This is the name of the variable, like if you see here, and this is the name of the variable. Now suppose if you want to do the same in SPSS, how you can do? You click on analyze. This is the procedure for doing regression analysis in SPSS, and you can see it's very easy to take data from SPSS to Excel, Excel to SPSS. Simply Control C, Control V and select paste with variable names. That's it. So click on analyze, regression, and there is an option called linear. So in SPSS we have a more choice. So there are different types of regression like curve estimation, partial least square, binary logistic, and so on. So just select linear. In Excel we are giving input and output range for Y and range for X. Here instead of input and output range, we have a dependent and independent. So, I have taken a wrong data set. Let me just Control Z, go back to Excel. I need law and criminology. Fine. So, let me just copy this because my intent is to show you there are no difference in the result generated by SPSS and generated by Excel. So just Control C, right click, paste with variable names. That's it. Go to analyze, regression, linear. So my dependent variable is crime rate and independent variables are these four. That's it. Simply click OK. So it generates the output. Look at the same output. Can you see the value of adjusted R square and R square? 0.972, 0.949. 0.972 because it's a 718, 972, 0.949. There is no difference in the result. Look at these coefficient 167, 0.50, 167, 0.50, minus 2.83, 0.471, minus 0.002. So this is constant. In Excel it says intercept. Look it. There is no difference in the answer. Either you use Excel or you use SPSS. F 43.228. Look at Excel 43.228. So it's not like that Excel is freely available, that's why it has no use. Either you use Excel or SPSS, results remain the same. So the procedure for doing in SPSS is like click on analyze, click on regression, linear, select dependent variable, independent variable and click OK, that's it. If you want to do it in Excel, then go to data, click on data analysis, select regression, provide input Y range where Y is range for dependent variable, provide input for X range. So this is independent variable. If there are labels in the first row, select labels in the first row, select the output option. You want in same sheet, different sheet or a new workbook, just click OK and you got the result. Now once when there are result, just only you have to interpret your result in a more meaningful manner. So you have to interpret the result of coefficient, value of adjusted R square, and this F test should be statistically significant. So this value is less than 0.05. So it indicates that your F test is significant. So your model is linear. There is no problem into it. So I think this is how you can use regression analysis, bivariate and multivariate depending upon your data. And I think procedure and interpretation is also very, very easy into this. So I think we will have a maybe around 10 minutes for question and answer.
Okay, thank you very much, sir. Participant, any question, query, you can unmute yourself or put the question in the chat box. Yes, any question, query?
Good evening, sir. Thank you. Today the session was very simple. I was able to understand. For the first time, I was able to understand what I need to do. Sir, I need to ask that if we are having multiple dependent variables, so while we are writing a research paper, is it enough to go only with the regression analysis?
No, it's basically depend upon what is your objective into it. Suppose if your objective is to predict, some dependent variable based on the information available for some independent variable, then I think regression analysis is sufficient enough to use in your research paper. There is no problem. So there are different technique has a different objective behind it. So the main objective of regression analysis is what? To know what is the contribution made by set of independent variables into a dependent variable, and based on that you can make some prediction or forecasting. So that's the main two purpose of regression analysis. So as you remember, in my PowerPoint presentation, how the way I keep the objective, in regression analysis. So
Yes,
what
sir.
was the objective for law and criminology? Objective was to examine how socio-economic variable influence the violent crime rate using legal and criminological lenses or the variables. Or
Yes,
suppose
sir.
when you do say law and education, so your objective is to know what, to examine how factors like internship, moot court participation, GPA, affects the career readiness into it. So suppose when your objective is of like this, and if you have a information on dependent and independent variable, either based on the survey you have conducted, or you can take secondary data also from some website or government reports, and you can use this regression analysis to make prediction. I think this is more than enough to incorporate in research paper.
Thank you, sir. Thank you very much, sir.
Thank you, madam.
Yes, any other question, query, participants?
See, regression analysis, for that matter, it is a slightly a long topic, and you have to do like practice, trial and error. You have to start like your regression model, y is equal to alpha say plus beta 1 x1, then you have to add x2, then you have to add x3, then you have to add x4. Suppose if you have a 5 independent variable, so you have to try with different combination and see which model gives you more higher r square, which model is better as far as concern of explanation purpose, and then you have to choose which regression model is more appropriate, considering your research objective.
Okay. Any other question, query, participants? Yes, sir, same thing should be used for forecasting. It's a different thing. Forecasting.
Yes, we can certainly use regression analysis for prediction and forecasting also. So forecasting is what? Say suppose we have estimated this model. I will just share the screen so that you will understand. So suppose this is our estimated model. Now for some city, you have a data on unemployment, you have a data on conviction rate, you have a data on police presence, and you have a data on poverty rate. So you replace those data multiplied with this 0.5 unemployment, this with this, then it will give you a some number. So that will be the predicted crime rate for that city. So this is how you can make prediction and forecasting of crime rate of some city depending upon availability of unemployment rate, conviction rate, police presence, and poverty rate based on this model. And you can rely upon this model based on the data of R square, because it says this model explained 97% variations in the your dependent variable. So it gives you reasonable amount, good amount of predicting power. Beside, if you are doing time series analysis, because time series regression is slightly different than this. So in time series regression, you have a data over a period of time, maybe for last 10 years or 20 years, or you are using monthly data or weekly data. So you can use those data and you can make either a short term prediction or a long term prediction also. So that is also possible using regression analysis.
Any is the last question. I think there are no such more questions. So
I think maybe at the later stage, if the participants have any question, query, doubt, they can always get back to me on my email address, or they can add me on Facebook also, or they can ask Dr. Kalpesh Gupta also, and we can, like, I'll try my level best to respond their queries.
sure, sure. So thank you very much, sir. On behalf of organizing committee, we are grateful for your sparing a wonderful time. And then especially used Excel. People, we just do basic thing with the Excel, but again, so many things can we do with the help of Excel. And then especially first time, this is also first time for me using Excel for regression and statistical analysis rather than doing some basic sum and then total that we do. So again, sir, look forward to seeing some future events and then programs. Sir. Thank you very much.
Yeah, it's indeed my pleasure always to be part of your program.
Thank you. Thank you very much.
Yeah.
So, participant, thank you very much for being a part of this program. I hope you got some insight from resource person's insight and then practical things. I request participant, any one of you can share your experience in 5 minutes. We wind up after 5 minutes, so you can unmute yourself, introduce yourself, and then say what you want to say about your experience last 5 days. Yes, please. Anyone. Yeah, thank you, Amit, Nitu. Yes, please unmute and communicate.
Good evening, sir. Good evening to all. Thank you for giving us a hands-on experience on the SPSS. Uh, we really learned a lot from your sessions. Thank you, sir, and thank you, organizers.
Thank you. Thank you very much, Dr. Revati. Yes, anyone else? Yes, thank you, Amit. Thank you, Nitu. Yes, anyone else? Thank you, Juliusri. Yes, sir. Yes, so over to Abhilash. Abhilash Nirvan, over to you.
Once again, good evening, everyone. Thank you to all the participants. Thank you, Professor Gaurang sir, for the effective session. As we conclude today's enriching session, I would like to take a moment to express our sincere gratitude to our Professor Gaurang Rami sir for his insightful session on linear and multiple regression. Your clear explanation, along with hands-on practice, have significantly enhanced our understanding of these essential statistical techniques. Professor Rami, your expertise has truly inspired us, and I hope everyone has well experience with the session. And we are grateful for your time and efforts in making this session both informative and engaging, sir. I would also like to extend our heartfelt thanks to all the participants for their active participation throughout the program. Your enthusiasm and dedication have made this journey more fulfilling. So, lastly, I just want to thank. We are deeply grateful to our esteemed dignitaries who supported us, has made this program possible. Our chief patron, Dr. Anil Tomar, Provost of Rai University, and patrons Dr. Dipesh Kumar Saxena, Registrar Rai University, and Dr. Asif Ahmed Malik, Professor and Principal, School of Law, Rai University, has been instrumental in ensuring the success of this initiative. Thank you for your continuous encouragement and guidance. Finally, as a reminder, the final exam for this capacity building program will take place on Sunday, 27th April 2025 from 2 p.m. to 3 p.m. I repeat, it is tomorrow, 27 April 2025 from 2 p.m. to 3 p.m. So I once again thank you to all the participants and thank you everyone. Have a wonderful evening. Thank you.
Thank you. Thank you very much.
Thank you. Thank
Thank
you
you,
very
sir.
much.
Thank you, sir.
Thank you, Abhilash, and then Nirvan.
Thank you, sir.
Thank you, all the participants. Thank you.